Look up at the night sky on a clear evening, and every planet you can spot seems to trace almost exactly the same line across the sky. Mercury, Venus, Mars, Jupiter, Saturn, they all appear to travel along one shared path because they all orbit the Sun in nearly the same flat plane. It looks almost too neat to be an accident, like the whole solar system was stamped out of a single flat disk. In a very real sense, it was. But here is the part almost nobody mentions in school. The one object in this whole arrangement that does not quite fit that flat plane is the Sun itself. The Sun's spin axis leans about 6 degrees away from the plane the planets share, a small but very real mismatch. Have you ever wondered why the star at the center of everything is the one thing that is slightly off? To understand why that tilt is strange at all, it helps to know how a solar system gets built in the first place. A star is born when a giant cloud of gas and dust collapses under its own gravity, spinning faster and faster as it shrinks, the same way a skater spins faster by pulling in their arms. That spin flattens the leftover material into a wide spinning disk around the young star, and planets slowly build up out of the dust and gas inside that disk. In 2014, astronomers pointed a huge array of radio telescopes in Chile at a young star called H. Tauri and captured one of the most famous images in modern astronomy, a disk with sharp, distinct rings, planets already carving out their own lanes. If planets form out of a disk that is spinning in step with its star, basic physics says the star and the disk should share the same orientation. So why does our own Sun lean out of step with its own planets? For years, one of the leading explanations involved a giant planet nobody has ever actually seen. Some astronomers propose that a hidden world far beyond Neptune, nicknamed Planet 9, has been slowly tugging on the rest of the solar system for billions of years, dragging the planet's shared plane out of alignment with the Sun. It is a dramatic idea, an invisible giant quietly bending an entire solar system out of shape over eons. But there is a completely different possibility, one that has nothing to do with anything happening later at all. What if the Sun was simply born tilted, the same way a person might be born left-handed, with no external event required to explain it? That question turns out to be much harder to answer than it sounds, because you cannot exactly travel back 6 billion years and check. The next best thing is to find stars that are being born right now, and check whether they come out of the gate already tilted. This is where the mystery gets even stranger, because the Sun is far from the only star with orientation issues. Astronomers have found hundreds of planets orbiting other stars on tilted paths, some of them dramatically so. A planet called WASP-17b orbits its star backward, moving in the opposite direction to the star's own spin, which is about as extreme a mismatch as you can get. For a long time, the leading theory for cases like that was chaos after the fact, close gravitational encounters between planets, or even entire planets getting flung out of their systems, leaving the survivors on crooked, battle-scarred orbits. That theory works well for systems that are already billions of years old, plenty of time for chaos to do its damage. But it says nothing about what a system looks like on day one, before any of that chaos could have happened. So astronomers went looking for the youngest, most isolated stars they could find, stars with no companion star nearby to complicate the picture, still actively building their planets. Earlier attempts at this existed, but they were tiny. The largest one before this looked at only 7 Sun-like stars, nowhere near enough to say anything with real confidence. A few other teams checked slightly older systems using something called a debris disk, a second-generation ring of dust and rock left behind once the original gas has cleared out, similar to the asteroid and comet debris still drifting through our own solar system. Even combined, those studies only covered 21 stars, barely enough data to guess, let alone prove anything. But even without a large study yet, There were already small clues that misalignment might be far more common than anyone expected. Some very young stars flicker unpredictably, dimming for days at a time in a pattern astronomers call dipping, and the leading explanation is that material from a tilted inner disk keeps drifting in front of the star's own light. Other disks show faint shadows stretched across their outer regions, cast by an inner disk angled just enough to block part of the starlight, almost like a sundial built entirely out of gas and dust. One recent survey using a sharp-eyed instrument in Chile found that 6 out of 11 young systems already showed a clear mismatch between their inner and outer disk regions alone. Astronomers even have a name for the imaginary flat surface that best represents the average orbital plane of the whole solar system, called the invariable plane, first worked out mathematically over 200 years ago by the French scientist Pierre-Simon Laplace. Compared against that invariable plane, the Sun's spin axis is still the one clear outlier, the exact same 6-degree tilt astronomers have never been able to fully explain. Here is a question worth sitting with for a second. If a third of newborn stars turned out to be tilted from birth, what would that actually mean for how we think planets and solar systems like our own come to exist? That is exactly the question a team of astronomers set out to answer properly, and this time they had a real toolkit for the job. One instrument was the Atacama Large Millimeter Array in Chile, the same kind of radio telescope that captured that famous ringed disk image, capable of measuring exactly how a young disk is oriented in the sky. The other piece came from space, from the TESS and K2 telescopes, spacecraft built to stare at stars and track the tiny dimming caused by dark star spots rotating in and out of view, which lets scientists work out how a star's own axis is tilted. Put those two measurements together, disk orientation from the ground, stellar spin from space, and you get a direct comparison between a star and its own planet-forming disk. The team assembled a sample of 49 young, single stars, each one similar in size to the Sun, each one between roughly 1 and 3 million years old, essentially newborns on a cosmic timescale. None of them had a known companion star nearby, which matters because a nearby companion can twist a disk all on its own and muddy the results. So what did nearly 50 baby solar systems actually reveal once the numbers came in? About a third of them, 16 out of the 49 systems, showed a clear, measurable mismatch between the spin of the star and the tilt of its own disk. On average, the gap between star and disk was about 17 degrees, and in a handful of systems, it stretched as far as 60 degrees. The team checked whether heavier stars, hotter stars, faster spinning stars, or any particular type of star were more likely to be tilted, and found no clear pattern at all. The mismatch did not seem to care what kind of star it landed on. So if it is not tied to the type of star, what is actually knocking these disks out of alignment before a single planet has even finished forming? A few candidates stand out. The gas cloud a star forms from is rarely calm. It is turbulent and chaotic, and that turbulence alone can twist a forming disk by tens of degrees before the star even finishes gathering itself together. Late arriving streams of gas, falling in from the whiter cloud around a very young star, can also shove the outer disk out of alignment well after the disk first formed. And in some systems, a planet massive enough can effectively slice the disk into two independent pieces, an inner disk and an outer disk, letting each one drift off at its own angle, sometimes by extreme amounts. Every one of those explanations points to the same conclusion. Misalignment is not some rare glitch that only happens to a handful of unlucky systems. It looks like a completely normal, common outcome of how stars and their planets are born in the first place. Which brings the story back around to our own sun and its own quiet 6-degree lean. The rest of the solar system, meanwhile, is remarkably flat. The mutual tilt among Jupiter, Saturn, Uranus, and Neptune is only about 0.3 degrees, and that flatness holds all the way out to the frozen debris of the Kuiper belt. The researchers went a step further and worked out roughly what type of star the young sun would have been, about 5 million years after it formed. Placed on that scale, the sun's own tilt lands squarely inside the same range found across the new sample, most of which sits somewhere between about 10 and 25 degrees. In other words, the sun's lean is not some unexplained anomaly at all. It looks like exactly what you would expect from a completely ordinary star of its age. Not a scar left by a hidden planet dragging things out of shape over billions of years, but very possibly something that was simply there from the very beginning. That does not settle the question completely, and the researchers are careful about that themselves. The angle they measured is technically a minimum, since the full three-dimensional geometry of a star and its disk is not always fully known, so some of these systems could be tilted by even more than what shows up in the data. And a primordial birth tilt does not rule out extra chaos happening later on top of it. The two explanations are not competing. They can both be true for the same system. The next major clue is expected to come from Gaia, a space observatory mapping the precise positions and orbits of stars and planets across the galaxy, data that should help track how these tilts evolve over billions of years. So the next time you look up and everything in the solar system seems to line up just a little too perfectly, remember that the one thing tilted out of place is the star holding it all together, and it was very likely leaning that way before a single planet around it ever finished forming.